The real impact depends highly of the vulnerable application itself. For example, a bank. It could be fairly serious because banks have transactions and sensitive personal information stored in there. Or, for example, some kind of hospital could have health records and such. On a somewhat infamous example would be from the 2005, there was this XSS-based SAMI worm, which was fairly harmless. It didn't do anything malicious. It exploited an XSS vulnerability and replicated itself to everyone who actually visited SAMI's. The guy was called Sammy. Everyone who visited Sammy's MySpace page, and then the worm replicated itself to the visitors page as well. And within hours, over 1 million users were infected. Fortunately, it didn't do anything malicious or anything like that, but MySpace had to shut down their service for quite a while in order to fix that. And another more serious example would be the Newegg stuff that happened. I cannot remember the name of the hacking group that executed it. But Newegg, they sell computer hardware and other electronics, and customer payment information was stolen over a period of about 1 month. And XSS was the exploitation delivery method there. But yeah, it can have very serious consequences as well. But on the other hand, if we have a web application that already has anonymous users and only public information, the impact, it basically would be negligible. Or if you have your own homepage that doesn't have any user information or anything like that, well, who cares? There's an XSS there. Wow, that's cool. Until someone actually exploits it for their own purposes and people start calling you that, hey, what is this thing? You should probably fix this. Fix your website, because you can be held liable for your own shortcomings within your website if other people use it to exploit someone else, just because your own platform is works as the delivery method there. But yeah, then we try to find XSS vulnerabilities. How do we find them? If they are so common, we can probably use automated tools. There are quite a few automated tools. This is just a couple of examples. We have Websuit, we have OWASP-Z attack proxy, we have XSSor and XStrike. This is not an exhaustive list. There are probably hundreds of different types of tools and platforms that you can use in order to find these vulnerabilities. But these are just a couple of examples. Then, of course, we have manual testing as well, which is very time consuming, but it often gives more results than just your automated tools. Except if you, let's say, if you get hired to do a pen test or such to a company X, then that company X wants you to find all vulnerabilities there. So you probably are going to use automated tools first and then manual testing after that. But manual testing, very time consuming, but more accurate than automated tools. Then prevention. What can we do in order to prevent these types of vulnerabilities within our own web applications? First things first, we need to filter all inputs or all user inputs based on what is required. For example, if we have a form where we require users to put in their phone numbers, we should probably blacklist all letters or weird symbols. So we should only allow numbers and perhaps a plus sign or such. And same with email, username. If we want only small letters, we should explicitly tell to the form that, okay, the user can input only small letters and such. That's the first line of defense. Next, encode all outputs where applicable. So, like in the examples before, we have search bars and such. And when we type something in there, our text gets reflected to the web page itself. So we can encode that text with different kinds of encodings. For example, we have HTML encodings, URL encodings, JavaScript and CSS encodings. We should probably use combinations of all of those in order to defend our functions and our web application. Next, we can use or utilize HTTP response headers. So to prevent XSS in HTTP responses that aren't intended to contain any HTML or JavaScript, we can explicitly use some response headers. For example, content type or X content type options headers to ensure that browsers interpret the responses in the way that we actually intend. And probably the last line of defense is CSP, which is Content Security Policy. Shortly, it basically restricts the resources that a page can load, like scripts and images and so on and so forth. But it's often fairly trivial to circumvent or bypass if someone really wants to. But when combined with all the other methods right there, it's basically the last line of defense, like I said. So it's very good practice to use it. And then we get to the example section. So real world example. So I found a vulnerability quite a while ago. I think these images are from 2017 or 18, something along those lines. And this has been fixed already. So there was a search bar for stuff, and when you write something in there, in this case QWE, because those buttons just are next to each other on the keyboard. And this is a small snippet from the source code that happened after that. After I pressed enter, I pressed Ctrl U, checked the source, and this is what I saw. There was a huge long line of text there, but our query, the QWE, is shown there. It gets reflected on the page as well. But there's something after it, as well as something before it. So again, like in the console.log example, we have to escape that in order to run our own JavaScript. How do we do that? Well, for example, like this. So first of all, we escape our query parameters with that single tick. Then we add the type thing. I honestly have no idea what it does, but it works if I did it that way. And instead of business, I just input nothing. And then we run our own JavaScript. So that way the JavaScript is valid, the query is valid. What happens is we get our alert box. That's pretty cool. And next, I am going to show you another demo over here. I made this thing, web application, right here, with some explanations. But here we have a practice box, which I created. So we can test this out. So if we type in test, press enter, your input, test, okay. And up here, wait, this is probably too small. Up here you can see test. We have vulnerable parameter aptly named equals test. If we try, let's say, rubber coast, reflect, it says rubber coast over here, rubber coast over here. Okay, what if we try HTML tags? Let's try big test. Reflect. As you can see, the text is bigger. And why is that? If we press Ctrl U, we can see the view source. Let's find our big test there. This is that part. Let's put it right there. Your input, big test. This is where it's located. So there's our tags, h1, and then we close the tag, and in the middle, big test. So we can use HTML here. So we can probably use JavaScript as well. And here's some testing I've done. Let's give it like cross-site scripting. That's probably fine. Click reflect, and there we go. We get our alert box. And you can see from here, script, alert, cross-site scripting, and then we close the tag. This is slash, but URL encoded. That's why it looks a bit weird. But this is basically what happens. Then we can get this link, copy it, and send it to someone. this is the link, and we can send it to our unsuspecting victim, and they will get the same alert box that we created. That's basically the gist of it. Next, we have stored. So if we input test, we send it. There's our test. Let's say that hello there. We send it. There's ID2 says hello there, and so on and so forth. What if we want to do hi? Again, we can actually modify the HTML right here. So we can use HTML tags, so we can probably use script tags as well. Not necessarily, but probably. Let's try with a simple alert. I'm using alert because it's very easy, it's very short function name, and it's extremely clear when it works and when it doesn't. And then we close the tags. Now we should get an alert box with the number 1 inside it. We can actually type in something as well. If I try test 1, test 2 on the other end, let's see what it looks like. Okay, we get our alert box. And then it looks fairly normal in there. Test 1, test 2. Why is that? Let's see here. Let's put this one to the side. So here's our line. We are ID 4, ID number 4. There we go. Test 1. Then our script alert and /script, and then test 2. So this, all of this gets interpreted as JavaScript, so it doesn't get rendered on the page itself anymore. It gets executed, well, rather this part. But this is not inside the script tags, so it's just HTML, it's just our message. And that's how it works. I hope that this cleared a bit how the attack itself works. And we can check out one more example right over here. So this is my own server. Where cross-site scripting has been gamified. So this is basically a game with levels and all that. A puzzle game, if you will. I have a couple of hints here as well on the side, but this is basically the same example that I showed you earlier. So when we type in stuff, anything, this is our payload, basically what we type in here. If our payload is long enough, it's annoying to look from or scroll this thing around. So here we can just see the whole thing. And this is console.log. And we can actually check our console while doing this. Let's type in test. There we go. That console.log actually gets executed every single time I update this bar, right? So what can we do? Well, let's just follow the rules. Escape this. So we can, firstly we can close this one. This is how it looks now. This is valid. This is invalid. Let's make it a bit more pleasing there. And then in the middle, we can basically write our own JavaScript. And the objective is to run alert 1 on all levels. And there we go. We don't get the alert box because, like I said earlier, it's really annoying when you see it for the thousands of times, same alert boxes. So I just replace it with a green win text. So this is the first one. We have escaped the console.log. Run our own JavaScript function, in this case alert, and then we even close the function to make it work properly. And there are multiple different levels, different types, different difficulty levels for all of those. And we can check some of those out, but not all of them. I'm going to give you access to this if you want to try it for yourself. It's completely fine. It's completely legal. You're not doing anything illegal. You have my permission to do so, as long as you just don't, you know, attack the server itself or anything like that, which I highly doubt. But yeah, we have multiple levels. This is level 2. Just for example, let's see this one as well. So here we have something else. We have the console.log, just like we had last time, but we are also replacing something. And this is basically just JavaScript and programming knowledge. And there's nothing really more than that. So if we try the exact same thing, we can see that it doesn't work. Why? Well, because of these backslashes. Backslashes escape the next character that gets typed in. So as we can see here, if you can see here, there we go, now you probably can. As you can see here,